Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 52 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from Algebra. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, please like the video, share this video with your friends who are preparing for CAT, and most importantly, for more such videos, subscribe to this channel. In case if you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. The link is provided in the description below. Now, once you sign up, you'll get access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD, and VR. We'll be uploading 100 tests in each section, and these are absolutely for free. So if you are a serious CAT 2025 aspirant, you cannot afford missing these tests. So without any further delay, let's get started. Now coming to the first question. If 6x square plus mx plus 2 greater than or equal to 0 for all real x, then how many integer values can m take? Now let me consider y is equal to 6x square plus mx plus 2. Now this should be greater than or equal to 0. So one case, let me consider equal to 0, and in the other case 6x square plus mx plus 2 greater than 0. Right. So what do you mean by y greater than or equal to 0? If I draw a coordinate plane, right? So the graph of this expression y is equal to 6x square plus mx plus 2, that can be either like this, then y is equal to 0, or y greater than 0. It should be like this. Right. You cannot have the graph of the equation y is equal to 6x square plus mx plus 2 like this. Y cannot be negative. Now this is not possible. So from the graph, we can understand that this equation should have either exactly one root. That means both the roots have to be equal, or no real roots, right? So for both the roots to be equal, your discriminant should be 0. For no real roots, your discriminant should be less than 0. Now combining these two, I can say that your discriminant should be less than or equal to 0. Now what is the discriminant? B square minus 4ac. Now we have b as m square minus 4 into 6 into 2. This should be less than or equal to 0. So m square minus 4 into 2, 8, 48 should be less than or equal to 0, or m square should be less than or equal to 48, or I can say that m should be minus root 48 less than or equal to m less than or equal to root 48, right? Now it is also mentioned that x should take integer values only, right? So square root 48 will be 6 point something, right? So integer values of m can range from minus 6 less than or equal to m less than or equal to 6. So how many values do we have? From minus 6 to minus 1 you have 6, 1 to 6 we have 6, and x can also be 0. So in total you have 13 values that m can take. So the answer for this question should be 13. Now coming to the second question, how many real values of x satisfy the equation x square plus 5 mod x plus 6 is equal to 0? Right. Now what do you mean by mod x? X can be either negative or positive, but it will be taking the positive values, non-negative values of x only. Right. So you can have x greater than 0 or x less than 0. Right. So if x is greater than 0, this will be x square plus 5x plus 6 is equal to 0. But when x is less than 0, so x square minus 5x plus 6 is equal to 0. Right. Now if I factorize this, we'll be getting x plus 2 into x plus 3. Now this is equal to 0. Now if I factorize this, we'll have x minus 2 into x minus 3. Now this is equal to 0. Now when will this be equal to 0? When x is equal to minus 2 or x is equal to minus 3. And this will be 0 when x is equal to 2 or x is equal to 3. Now if you observe, we have assumed x to be positive, right, greater than 0, but we have the values of x in negatives. Not possible. And here we have assumed x to be less than 0 and we have the values of x being positive. No. Right. So the answer for this question that has to be 0. We do not have any value of x that satisfies this equation. Right. Now let's look at the shortcut way of solving this question. Now we have x square plus 5 mod x plus 6 is equal to 0. Now for any real value of x, this is non-negative, right? Or except for 0, let me consider this to be positive. Because when I replace x with 0, you do not have 0 here, you have 6, right? So for any real value of x other than 0, you will be having this to be positive. Similarly, 5 mod x, this is positive and 6 is also positive, right? Now can we have sum of three positive numbers being 0? No, right? So we do not have any value of x that satisfies this equation. Now coming to the third question, find the number of integer solutions to mod x minus 1 plus mod y plus 1. This should be less than 5. Now let's start with minimum value of this. Now what is the minimum value of mod x minus 1? 0. Now if this is 0, right, this could be 0 or 1 or 2 or 3 or 4. Right. Now for this to be 0, y plus 1 to be 0, right? So y can take only one value, which is minus 1. Now for y plus 1 to be 1, right? So y can take either 0 or minus 2, right? If I consider y to be 0, 0 plus 1 is 1, or minus 2 plus 1, minus 1, modulus of minus 1 is 1 again, right? So you have two values here, right? Now for y plus 1 is equal to 2, then also you will be having two values. Y is equal to 1 or y can be minus 3 also. Two values. Again you will have two values, two values. So when x minus 1 is 0 and when x is 1, you have how many? 1, 1, 2, 3, 4, 8, 8 plus 1. 9 possible different values of x and y. Right? Now when x minus 1 is 1, now, for x minus 1 to be 1, again you have two values. X can be 2 or x can be 0, right? Y can be 0 or 1 or 2 or 3. Y cannot be 4 because that has to be strictly less than 5, right? So you have one value here. For this you have 2. For this you have 2. For this you have 2. So in total, 6, 6 plus 1, 7, right? And again, there are two possible values of x for x mod x minus 1 to be 1, right? So 2 into 7, 14. Now when x minus 1 is 2, if this is 2, y plus 1 can be 0 or y plus 1 can be 1, 2, right? This cannot be 3. Now 2, 0. For x minus 1 to be 2, we can have the values of x as minus 1 or 3. You have two different values, right? We have one value when y plus 1 is equal to 0, two values when mod y plus 1 is equal to 1, and two values when mod y plus 1 is equal to 2. So in total you have 5, 5 into 2, 10. Now when mod x minus 1 is equal to 3, then the values that x can take are minus 2 or 4, right? And the corresponding values of y plus 1 can be either 0 or 1, right? So you have two cases. Y plus 1 will be 0 only when y is equal to minus 1, and for mod y plus 1 is equal to 1, now you should be having the value of y as minus 2 or 0. You have two possibilities. So 3 into 2, 6. And when x minus 1 is equal to 4, now this has to be 0 only. Now for x minus 1 is equal to 4, you have two values for x. X can be 5 or x can be minus 3. Two values, right? So for y plus 1 is equal to 0, you have only one value for y, minus 1, right? So 2 into 1, 2. So how many do we have? 14. 14 plus 6 is 20. 20 plus 10 is 30. 30 plus 11, 41 should be the answer for this question. So there are 41 order pairs for the values of x and y that satisfy this inequality. Now coming to the fourth question. 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square so until minus 100 square. Now what I will do is we have 1 square minus 2 square plus 3 square minus 4 square so until minus 100 square. Now I will be adding 2 square plus 4 square plus 6 square so until plus 100 square, and at the same time I will be subtracting 2 square, 4 square, 6 square so until 100 square, right? So 1 square plus 2 square plus 3 square plus 4 square plus 100 square. Now we have sum of the squares of first 100 natural numbers, right? So 1 square plus 2 square plus 3 square, so on till 100 square minus 2 times of 2 square plus 4 square plus 6 square, so on till 100 square, right? Now, first 100, sorry, sum of the squares of first 100 natural numbers, 100 into 100 plus 1 into 200 plus 1 by 6 minus, now let me take 2 square common. So you will be having 2 into 2 square into, you will be having 1 plus 2 square plus 3 square, so until 50 square, right? So sum of the first, sorry, sum of the squares of first 50 natural numbers. So n into n plus 1 into 2n plus 1 by 6, right? Let me write this as 101. Now what can I take common? I can take 100 into 101 by 6. Then we'll be having 201 minus. Now we have 100, 6 and 101. Now 2 square, 4. 4 into 51. 204. Right? So 100 into 101 by 6 into minus 3. So 100 into 101 into minus 3 by 6. Now this is 2, this is 50. So 50 into 101, 5050 with a minus sign. Hence option D should be the answer to this question. Now coming to the last question, find the number of non-negative integer solutions xy satisfying the inequality 2x plus y less than or equal to 10. Now non-negative, so the values of x and y can be 0. Now if I place the value of x as 0, the value of y can be from 0 to 10. You have 11 values that y can take. Now if the value of x is 1, so y should be less than or equal to 8. So y can take any value from 0 to 8, 9 values. And the value of x is 2, right? Y should be less than or equal to 6. So from 0 to 6, 7 values. When the value of x is 3, y should be less than or equal to 4. So 0 to 4, 5 values. When the value of x is 4, y can take 3 values, and when the value of x is 5, y can take only one value, which is 0. Right. So how many do we have? 11 plus 9, 20. 20 plus 12, 32. 32 plus 4, 36 should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.